Hello, I'm Shivam Dalmia from MSRIT 8th Sem Computer Science and Engineering. I'm going to present a seminar on the deep web. The deep web is essentially a set of data on the internet that cannot be accessed by traditional search engines as they cannot be indexed. What search engines do is that they use programs called crawlers to navigate through web pages by following links. They then construct a database of all available information from which results are returned on query. However, it's only a small fraction of the wealth of information available on the internet. What can be indexed by search engines forms about 4% of the total web content, while whatever cannot be indexed forms 96% of the digital universe. This is about 7.9 zettabytes of information, which is clearly a lot of information. We can see that the deep web is about 400 to 550 times the size of the surface web. The deep web consists of dynamic content and scripted content, unlinked content, private web and limited access content, consists of the contextual web, it consists of non-HTML and non-text content and non-HTTP content, and finally it consists of virtual private networks and onion networks. We look into each of these now. Dynamic content or scripted content is content that is returned through a form or through a query. These include links produced by JavaScript as well as content dynamically downloaded from web servers via Flash or AJAX solutions. Now, this is something that is dynamic content because it is constantly changing. It changes every day. When you search for the value of $1 in Indian rupees, you get the value for the day. Now, if I were to do this today, I would have a different value altogether, as you can see. It has fallen considerably. The next content that we can find in the deep web is unlinked content. Unlinked content is pages that have no links incoming to it from other pages, and therefore web crawling programs, which I had mentioned earlier, cannot access this content. This content is also referred to as pages without backlinks or inlinks. The search engines like Google especially use the number of inlinks that a page has as a measure of importance of that page. We can see this Wikipedia article is an orphan because no other article from Wikipedia link on it. So the only way to access this article would be to actually go and search for Intel 80130 on Wikipedia. The next part of the deep web is private web content and limited access content. Private web content is any site or any part of a site that requires a ID and a password to log in. This contains user-specific data which only the user with the correct credentials can access. Limited access content is content that is specifically designed to prevent certain software programs or bots from accessing it. Basically, it is to ensure that the user accessing the content is human. So things like robot exclusion, standard captchas, or no cache pragma HTTP headers can prevent search engines from accessing certain content and thus being part of the surface web. A contextual web consists of information that is returned by certain programs on a query by a user. For example, contextual advertising, which is a form of targeted advertising, which returns ads related to a user's search term alongside the search results. So, for example, here, when the user searched for South Africa, he had sponsored links related to perhaps South Africa tourism. Finally, we have non-HTML and non-HTTP content. Non-HTML content is anything that is not in the format of HTML pages or not in a format that search engines can understand. For example, text encoded images such as this text right here and maybe in videos, etc. Certain file formats can be accessed by search engines, namely PDFs. The other contextual content falls under non-HTML content. And non-HTTP content is also part of the deep web because they can obviously not be accessed by search engines. So this includes Gopher, FTP, email, etc. Now let us try to understand what we mean by depth of the deep web. The surface or visible web is like the surface of an ocean, which can be crawled or which can be searched by search engines such as MSN, Yahoo, and Google. The crawler can only look at the surface content, whereas there is a lot of deep content such as specialized databases, non-conventional formats, paid information, and restricted information, dynamic web pages, which we discussed, that cannot be accessed by the search engines. Now, the deep web necessarily doesn't need to be searched because there is obviously certain content such as restricted content and non-HTTP content which need not be searched by the search engine. That is the whole point of having that. However, there are a lot of resources and a lot of files and other information that could be useful but that cannot be searched by search engines. And thus the concept of federated search comes in. Popular search engines crawl websites for links, but they're not able to search databases. Federated search engines is a category that searches multiple online databases or web resources. So there is a lot of high quality business, scientific and technical research in the deep web, which can be accessed by federated search engines. These engines perform simultaneous searches on different databases and consolidate the results so that the user does not have to visit the individual sites. The quality is much better and the search is deep but narrow. That is, it can search only maybe a few websites. But, these could be organizations which are authorities on a subject. And they are real time, unlike traditional search engines, which, as discussed, crawl web pages periodically and may not be able to access the most relevant or the latest content of a web page. However, federated search engines do take longer to come up with results. This is because they depend on how fast the underlying database search performs. This is an example of federated search powered by deep web technologies. So using their proprietary search, if you search for something like academic routing on this particular website, you have a lot of resources that show up, which may not show up if you were to search this website through a normal search engine. Let us take another example of the same. If I were to search for string theory, say, on Worldwide Science, you can see that it takes a little time to complete, but you get HTML pages as well as other formats that are maybe not accessible by usual search engines. So this we can see it's powered by deep web technologies, and you can see that it's real time. It's throwing out results in real time, but it's taking a while to search the entire source of the information. When it eventually goes through the entire source, it will show up all the details. Here, for example. Now we come to the more unfortunate aspects of the deep web. Essentially, the deep web has nothing to do with illegal activity. Most of the deep web is non-illegal activity, that is very legal activity. We all access the deep web on a regular basis whenever we check mail or log into a social networking site. However, there is a aspect of the deep web called the dark web, which has numerous links to illegal activity or even perhaps legally hiding one's identity. It is a collection of websites only accessible over the Tor network, which hides your IP address and gives you complete anonymity. Not every website accessed over Tor is part of the dark web, since Tor allows you to browse anonymously on the regular web as well. However, Tor also allows at best using a special pseudo top level domain suffix called .onion, which is used to get to websites hosting themselves over Tor. Tor is actually legal. It is just a way of protecting your anonymity online. So people like the military, police, journalists, whistleblowers such as the famous Edward Snowden and Julian Assange have used it. But it has also become a nesting ground for criminal activity, and this includes unsavory things such as drugs, child pornography, weapons trading, and hitmen for hire. To take an example, we have something called the Silk Road. This was highlighted in Time magazine's November 11, 2013 issue. The dark side of the deep web, where criminals hide from surveillance efforts to commit nefarious deeds anonymously. A man called Ross Albright started something called the Silk Road, which is identified as the Amazon.com of illegal drugs, or the eBay for drugs. He was arrested for the same, and the Silk Road was shut down. But it was only a few days before its Silk Road 2.0 started, and you can see it's a portal to sell illegal and outlawed drugs and other substitutes. Let us look at what Tor is to understand how it is both a boon as well as a bane. Tor is free software for enabling online anonymity and censorship resistance. Tor was an acronym for the onion router. Now it's just known as Tor. Now, Tor directs internet traffic through a free worldwide volunteer network consisting of more than 5,000 relays to conceal a user's location or usage from anyone conducting traffic analysis or network surveillance. Tor was interestingly designed, implemented, and deployed as a project of the US Naval Research Laboratory. It had the primary purpose of protecting government communications. Today used for a wide variety of purposes by normal people, the military, journalists, law enforcement officers, activists, and many others. Let's look at how Tor works. We have Alice, who is trying to maybe reach Bob. First step is that she obtains a list of Tor nodes from a directory server. That's Dave. And then she creates a private network pathway. That is, she incrementally builds a circuit or encrypted connection to relays on the network. The circuit is extended one hop at a time, and each relay along the way knows only which relay gave it data and which relay it is giving data to. That is the previous relay and the next relay. No individual relay ever knows the complete path that a data packet has taken. Instead of taking a direct route from the source to destination, data packets in the Tor network take a random pathway through several relays that cover your path so that no observer at a single point can tell where the data came from or where it is going. Relays are hosted by volunteers using Tor around the world. The plus sign clients are the ones who are actively using Tor, and Alice sets up a connection to them. If the connection is set up one client at a time, that is, Alice sets up an encrypted connection with the first relay, and she has no idea which path the data is going to take. The second one sets up a path with the third one. The third one sets up a path with the fourth one, and the fourth one transmits the data to Bob. So each relay has knowledge of only the previous node and the next node, and no knowledge of where the data came from or where it is going unless it was the last to the first link. What happens when Alice tries to send a data packet in the next increment? What happens maybe to Jane? A different pathway is followed altogether. So she connects maybe to the second one, which connects to the third one, which connects to the fourth one, which connects to Jane. Here we can see the green links are encrypted, but the red links are unencrypted. So this is because the final node has to know what data it is sending to the receiver. Once a circuit has been established, many kinds of data can be exchanged and several different sorts of software applications can be deployed over the Tor network. Because each relay sees no more than one hop in the circuit, neither an eavesdropper nor a compromised relay can use traffic analysis to link the connection source and destination. Tor only works for TCP streams and can be used by any application with soft support. Let us look at the Tor browser and how it works. So I want to start the Tor browser. Takes a little while to start up, that is user network. This is the Tor network essentially. Very clear, but yeah. This is a list of active relays on the network and what kind of connections we have to all of them. Every time you want to change your IP address, use a new connection, use a new identity. This is the IP address that Tor has set up for this client. However, this is not the actual IP address of this client. This is the actual IP address of this client. Tor comes up with a different IP address. Another service that Tor offers is that it makes it possible for users to hide their locations while offering various kinds of services such as web publishing or an instant messaging server. Using Tor rendezvous points, other Tor users can connect to these hidden services, each without knowing the other's network identity. The hidden service functionality allows Tor users to set up a website where people publish material without worrying about censorship. Nobody is able to determine who is offered the site, and nobody who is offered the site knows who is posting to it. Unfortunately, this is where miscreants and criminals exploit the advantages of Tor. By hosting websites that promote illegal activities on the Tor network as hidden services, they are able to anonymously execute dangerous and harmful activities, including drug sales, distribution of child pornography, sale of fake documents, and even the sale of illegal firearms. Now, how does the Bitcoin influence this whole picture? We all know that Bitcoins use peer-to-peer technology to operate with no central authority or banks, managing transactions and ensuring that Bitcoin is carried out collectively by the network. Bitcoins are sent easily through the internet without needing to trust a third party. The transactions are irreversible by design, fast, not at all costly. The main feature of Bitcoin transactions is that they are anonymous. Nobody needs to know who is paying whom. So it is the currency of choice for any illegal activity on Tor. So we can see that in 2011 January, Silk Road was founded. In February, the Bitcoin tripled in value. In June, the investigation between the links between Bitcoin and Silk Road started, and in November, Bitcoin fell by over 90%. In 2013 October, the person accused of being the owner of Silk Road was arrested and Silk Road was shut down. But in November, Silk Road 2.0 started and Bitcoin tripled in value. So we can see that the relation between Bitcoins and the Silk Road has been quite parallel, and though there are advantages to using things like Bitcoin and Tor, there are obvious disadvantages as quite evident. Let us look at the advantages and disadvantages of Tor finally. The advantages are that normal users can use it to protect anonymity, preserve privacy, and prevent censorship of legitimate content. Military agencies can use it to protect operations, conceal geographic location, and host services that are difficult to discover. Journalists use it to avoid censorship, especially in countries like China, where censorship is a big issue. Law enforcement officers can use it for online surveillance and tip lines. There are email services and messaging services, etc. on Tor that make it impossible to track the origin and the receiver of messages and emails. Activists and whistleblowers like Edward Snowden and Julian Assange use Tor to protect their identity. Business professionals employ Tor to trade confidential information that needs to be kept secret from the public or other competitors. Disadvantages are mentioned here. Illegal websites such as drug marketplaces, gambling, child pornography distribution, fake document sale, etc. Distribution of disturbing and unsavory images, and details of any illegal activity that they can't be traced. There's the potential for hacking and spamming. However, it's not so easy to hack through Tor. There are ways and means that Tor has implemented to protect such issues. It is easy to make uncensored, abusive, racially maligning comments on forums and messaging services through Tor. Bitcoins allow the trade of weapons, threats, etc., as well as gambling, providing complete anonymity even when making large transactions. To wind up, here is an image that effectively shows what the deep web looks like. So here we have the surface web where Google can crawl and access content. We have the deep web where government, whistleblowers, hackers, and undetected content lie, as well as the unfortunate illegal content. And in summary, we have shown what the deep web is. It is analogous to an ocean whose surface can be tracked to content by various search engines. However, their depth cannot be remotely reached by these service providers, and this is called the deep web. The founder of Bright Planet, Mike Bergman, coined the phrase deep web and said that searching on the internet today can be compared to dragging a net across the surface of the ocean. A great deal may be caught in the net, but there is a wealth of information that is deep and therefore missed. Therefore, it in effect includes dynamic, scripted, and contextual content that cannot be indexed as it is constantly changing. However, the need for indexing such pages is minimal. It also includes password protected and limited access data that obviously should not be searchable. However, what is important is that for the consumer, important data cannot be found by a web search, which includes data in files, images, and databases. These represent a wealth of available information that can yield more accurate results than traditional searches. Hence, the concept of federated search and deep web harvesting, which searches narrowly but deeply, assumes importance. Additionally, we have a system to browse the internet anonymously, which also allows the hosting of pages not indexable and not accessible by ordinary browsers. These hidden pages constitute another part of the deep web and shady subset, the dark web. While Tor allows users to preserve privacy and anonymity while accessing and hosting content, antisocial elements seek cover in this secrecy and perform dangerously criminal activities. That is the end of my seminar. Thank you for watching.